Welcome back, participants. We are delighted to welcome back Mr. Mohammad Riaz, Vice President Technology at JP Morgan Chase, Singapore, as the distinguished speaker for the session 13 on case studies and industry use cases of data science. He was also the speaker of session 3, where he delivered an insightful session on exploratory data analysis and data visualization. With over 20 years of experience in finance and technology, Mr. Riaz has led transformation programs, platform adoption, and regulatory initiatives across global firms, including JP Morgan, Credit Suisse, and Ernst and Young Advisory. He is equally passionate about mentoring global teams, driving learning programs, and contributing to senior leadership forums. In addition, he holds multiple global certifications like PMP, ITIL practitioner, AWS cloud practitioner, and financial markets certification from Yale University, reflecting his strong blend of technical and financial expertise. In today's session, he will share the real world case studies and industry applications of data science, giving us practical insights into how organizations are leveraging data for innovation and decision making. We are truly honored to have him with us again today, and we look forward to learning from him, from his expertise and experience. Welcome, sir.
Thank you. And thank you for giving me this opportunity to be part of this forum again. Let me share my screen. Okay. Can you see my screen?
Yes.
Okay. Okay. So today's session is going to be we're going to be talking about some of the data science applications across different industries. So we'll examine how data science transforms business operations, it delivers a lot of competitive advantages, and also provides a lot of innovative solutions to complex programs. So the objective of this session is for you to gain some insights into real-world case studies and then some practical strategies to implement data science initiatives in your own organization. So from an agenda perspective, you start off with a very high-level introduction to data science in the industry side of things. I think you have already had a lot of sessions focusing on the in-depth from data science concepts. Then we'll look at in more details of the real-world case studies from the leading industries. And finally, if we have time, we'll just do a quick overview of how to generally manage data science projects in your industry. So we'll start off with the introduction to data science in industries. As you know, data science is transforming industries by enabling smart decisions through data-driven insights. So we will look at more on some of the applications and also what are the key trends shaping the industry today. So an overview of how data science is applied across different sectors. So you can see we have healthcare applications. So typically it revolves around patient care through predictive analytics and also personalized treatment plans. On the retail side, we use data science to enable personalized marketing. As a classic example, Amazon, I'm sure you're all familiar, Amazon's recommendation engine is driving 35% of their total sales just through personalized product suggestions. And this is typically based on your browsing history, your purchase patterns, and also similar customer profiles. Another retailer, Target, which is actually a pharmacist, a very big pharmacist, especially in the US, they have developed algorithms that could actually predict customer pregnancy. So they can actually know that, like, guess if the customer is actually pregnant through purchasing pattern analysis and also allowing them to do more targeted marketing campaigns. And then on the finance side, a very strong use case for data science is fraud detection. So financial institutions apply machine learning to detect and prevent a lot of fraudulent activities. JP Morgan Chase, for example, has implemented AI systems that actually reduce the false positives in fraud detection by almost 60% and improving actual fraud identification by 80%. Now, again, these systems typically they analyze the patterns of how the transactions are happening, the geolocation data, basically from where, which location to which location, and also customer behavior in real time. And then these systems flag out any suspicious activities. So in essence, data science continues to revolutionize industries by transforming raw data into actionable intelligence. A few other sectors where data science is making an impact, manufacturing side, so typically more proactively finding problems through or preventing problems through predictive maintenance, and also much better quality control, basically overriding the manual quality checks with automatic checks. In the transport sector, more on the logistics side, data science is widely used for logistics route optimization, saving companies a lot of money, and also forecasting demand for transport. In the energy sector, we have a lot of optimization being done using data science, machine learning to optimize how energy is being produced and also to create a balance or balance it against the demand for the energy. On the agricultural side, a lot of innovations is happening again using data science, typically precision farming, crop prediction of what will be the crop yield. Those are the key things that's happening. So we'll deep dive into these sectors, industries in more detail on the upcoming slides. So just a couple of quotes to kind of highlight or remind everybody of how data science is changing the world, changing the way industries are looking at it, and the way they are outrunning themselves or challenging themselves. A couple of quotes. So from Andrew Ng, uh, he says, like, just as electricity transformed everything 100 years ago, he thinks that AI is going to achieve a similar transformation, which is going to be of very high magnitude in the next few years. And then there's a quote from The Economist, which says the world's valuable resource is no longer oil, but data. So that's where you know where to bet your money on. So let's take a look at some of the key trends that are shaping the different industries that we went through earlier. So at the top of the list is automated machine learning or automated auto ML. So automated machine learning compared to typical older machine learning models, which are more time consuming and more requires more human interference to create the models and so on. AI, sorry, AutoML actually makes it much more streamlined. So it makes AI development faster and more accessible as well. So Google's AutoML Data Robo platform, so they are actually today already allow organizations to develop sophisticated machine learning models without you having extensive expertise on data science. This is really a big kind of a major kind of a democratization that has reduced model development time from months to days in many organizations. The impact from the AutoML is, for example, a company like Airbus, as you know, a big airplane manufacturer. They are using the AutoML to optimize aircraft designs, and typically they are able to achieve reduction of development cycles by 30% and also improving the fuel efficiency by analyzing thousands of design variables simultaneously. So the basic benefits of AutoML are faster results, and it's much easier for non-experts. So even if you're new to the world of data science, you can easily pick up AutoML for building models. Then second on list is big data integration. Again, I think you've already had multiple sessions on big data. So you do understand integrating big data basically enables the industry organizations to analyze vast, big, mega-sized data sets and making their decision making and providing more insights much more fruitful. As an example, the big US retailer Walmart, they process over 2.5 petabytes of data every hour from customer transactions, inventory, and social media. And they use this information to optimize the entire supply chain operations. And from a statistics perspective, if you're familiar with the retail side, out of stock, typically it means that the chances of or the number of instances when the Walmart shelves run out of stock of particular items has overall reduced by more than 30%, and also they have better inventory turnover. Another example is Netflix. So Netflix, as you know, they also analyze the viewing habits of their over 220 million plus subscribers, and then they provide you with personalized content recommendations. And this again has translated to almost an 80% content discovery through their recommendation systems. Okay, so overall for big data integration, the key benefits are you get to see the whole picture. So basically by combining data from many sources instead of looking at one or two sources, it gives you a much bigger view of where the problems happen or where to improve. It also gives the industries a chance to decide faster and give them more confidence. Next, we talk about ethical AI. So ethical AI is a very big topic in the industries today. As you know, it ensures responsible, fair, and transparent use of AI technologies. Microsoft and IBM especially have established a lot of AI ethics boards to review application and prevent algorithm bias. Then a lot of organizations are continuing to improve, like adopt these frameworks, including Google also provides a responsible AI practice to ensure fairness and accountability. So AI ethics is definitely important to protect people and also prevent bias and be open and accountable. Next, we have edge computing. So edge computing is nothing but it's a method where we process data closer to the source, typically for time-sensitive or real-time applications. So so Tesla cars.
என்ன கொண்டு போறீங்கன்னு கேட்கல
So
Sorry for the interrupt.
no problem. Go back to the screen share. Okay, so talking about edge computing, Tesla cars are a classic example of edge computing. So they actually provide real-time. So basically, the vehicles actually process sensor data locally within the cars to make those split-second driving decisions without relying on cloud connectivity. Manufacturing plants, sometimes, again, those time-critical ones, also use some kind of edge devices to monitor equipment performance, and any maintenance needs are immediately alerted, thereby reducing downtime by a lot of percentage. And lastly, quantum computing, as you know, is the new kind of computer power that can actually test many possibilities at once. So again, from AI data science perspective, it is a major data science trend that's reshaping how the industry, how companies are working today and will compete tomorrow. So just to share a quick insight in terms of the projections of Fortune Business Insights as of August 25, they are projecting the global data science platform market to grow from 133 billion in 24 to almost 777 billion in 7 years from now. So that's like almost a 25% compound annual growth rate, which is huge. And if you see the second chart there, it also gives you like a high-level breakdown of what is the share of industries that are actually going high on adopting data science as part of their activities. So BFSI, banking and financial services leads the pack, closely followed by IT and telecom, and then healthcare. So let's step further. We'll look at some of the real world case studies from some of the leading industries in this section. So we start off with healthcare. So healthcare, typically the major use cases are predicting patient outcomes, proactive care, and also resource allocation. So for predictive patient outcomes, so typically we have a lot of machine learning models which analyze patient data and they try to predict what would be the outcome of the patient's health based on various parameters. As an example, at Massachusetts General Hospital, again, the US, they have built an ML machine learning algorithm which actually predicts with 76% accuracy as to which patients would develop severe respiratory distress 48 hours before the onset. So they're able to predict 48 hours before the patient starts developing serious respiratory troubles. Now, typically, these models, the data that they derive from is electronic health records like the patient's demographics, diagnoses, treatments, lab results, vital signs monitored over time, genetic markers, family history information, then psychological or personal factors like social, housing, education, income. And with the advance of technology, a lot of people now have wearable device data tracking and sleep patterns as well. So that data also forms a part of it. Then next, in terms of proactive care, so predictive, this is more of a byproduct of the previous one. So once you have a lot of predictive patient outcomes, automatically it helps the healthcare providers or the doctors or the supporting staff to offer proactive and personalized patient care. So able to, instead of trying to firefight, they already know, okay, there's a high chance of something going wrong. Let's try to prevent it. Um, a quick example of one of the healthcare systems, which is called Intermountain Healthcare. They built a sepsis prediction system. For those who don't know what is sepsis, it's something called, I think in layman terms, it's called blood poisoning. It's a very, if it can, it proves to be fatal in a lot of cases. So they built a sepsis prediction system, which actually analyzes 800 plus clinical variables, and this helps them identify patients who are at a risk of getting sepsis at least 24 hours before the symptoms start to appear. So this has helped them reduce, on average, the fatality or the mortality rate by 20%, and even hospital admissions or the hospital stays by 17%. And lastly, resource allocation. So again, machine learning data science helps the hospitals or the healthcare systems to allocate medical resources based on the predicted patient needs. So as an example, there's a hospital called Providence and Joseph Health. So they use AI to forecast patient admissions, and they have been able to achieve 95% accuracy, which is really big. And this helps them optimize the staffing levels and reduce their unnecessary overtime costs by almost 4 million annually. So these are really big wins in the healthcare industry. A few more examples from the healthcare industry. So there's, I think all of us, COVID-19 is still fresh in everybody's minds, I'm sure. So as you know, for COVID-19, one of the major reasons for fatalities or deaths was respiratory failure. So Northwell Health Study, they were able to build a machine learning model called XGBoost model, and they were able to achieve very high predictive accuracy for a patient within 48 hours. So basically, uh, they were able to predict to a great extent whether a patient is bound to get respiratory failure 48 hours prior. So this gave them, again, same thing, a better chance of survival and for the healthcare system to support the patient. Another example is Cleveland readmission risk model. So this is again more of trying to prevent or proactively prevent patients from coming back and getting admitted again and again. So proactive monitoring and preventive kind of healthcare. So they were able to build a model that was able to um, predict high-risk patients with almost 85% accuracy. and they achieved reduction of patients getting readmitted to hospital by almost 22%. Okay, so it's a quick short video. Let me play it just to give you an example of a real life use case in healthcare, which uses Google Cloud AI.
It's not audible.
Sorry, so the video audio is not coming up. Hello.
Yes, sir.
Yeah,
Yes, sir.
yeah.
Okay. Let me then. Can you hear now?
No,
Sorry.
sir. It's not
No?
audible.
Okay, let me stop sharing.
That infection has got out of control and you're in a state of sort of attrition warfare.
It's audible now.
Thank you.
What really attracted me to sepsis research is if you predict it early and put patients on antibiotics, you can potentially save lives. There has been a few attempts in the past 10-15 years to predict sepsis. However, many of those algorithms, they had a fairly low performance. Over the past few years, with better analytic tools such as deep learning, artificial intelligence tools, we have been able to improve the accuracy of these models. Definitely setting up the data was probably 70% of the work. It took us a year to figure out how to get the data, in what format. There were times that I thought it's just not going to be possible. The first time we built the model, it was based on only 400 patients. And our latest data pool is about 450,000 patients. With the advent of better AI algorithms, we are able to look at now many different indicators. In our latest work, we were looking at 65 different indicators. Some of them comes from laboratory, from patients' vital signs. Some of them are coming from bedside monitor data, and it's becoming impossible to process this data on our desktops locally. So that's where some of the cloud resources becomes very useful.
Shuman is one of the smartest people you'll find anywhere in the area of sort of time series analysis and deep learning. He's working much more on the AI side of things. I'm working much more on the system side of things. In our current system, we've sort of tightly coupled how we're fetching data from.
Yeah, so I'm not playing the full video, but it's I think further on is just going to talk more about how they set it up on the Google Cloud. That's something which you can also explore in the interest of time. But the key point to highlight there was how the data science plays a key role, especially some of the key points. If you noted, they started off with 400 patients of data, it grew to 450,000 patients, and then they are monitoring like 65 different data points or variables are being looked at to predict and make those predictions. Okay, so let me move on. So after healthcare, so the next industry we'll look at is retail. So I think anyone who is a fan of shopping, I'm sure, has explored all the retail shopping applications that are out there. Now, For retail, the key impacts of data science are for the retailers to create a personalized shopping experience. So data science basically powers the personalized product recommendations, thereby enhancing customer satisfaction, and also generally customers can become more more loyal when they see some personal preferences being targeted at them. Again, taking an example of Amazon. So Amazon's recommendation engine actually generates 35% of total sales just through its two options. Again, for those who have used Amazon, you should be familiar. It's called customer who bought this also bought something else. And then there's a section called recommended for you. So these features alone, according to Amazon, generate almost 35% of total sales. Basically, when you see another item and you click on that, it becomes part of that number. Now, how do these systems work? Basically, they analyze the purchase history. So what are you purchasing? Your history of purchases, and your browsing behavior. How do you scroll through the application, the products, the product rating patterns, review sentiments, how much time actually you spent on viewing specific items, your location, demographic information, location data, and they also look at things like seasonal trends and product associations with related products and so on. And then from retail perspective, the other aspect is inventory management efficiency. So again, when you think of a supermarket or something like that, you can imagine like making sure that they don't really run out of stock of the key items. So managing the inventory becomes key. So far, I think it has been a lot of manual things, but now with data science, it is becoming much more easier to optimize the inventory management. Now, again, taking the example of the big retailer Walmart, so they actually use sales data. They look at seasonal patterns. They look at local events. They even look at weather forecast to predict their demand. And to be surprisingly, they actually are able to achieve almost 90% accuracy in terms of making that prediction. And this in turn has helped them reduce their stockouts by 16%, and they able to save almost $1.2 billion annually just for the inventory holding costs. Another famous retailer is Zara. So they also use predictive analytics to optimize their inventory across almost, I think there are more than 2,500 stores worldwide. So their system processes the daily sales data, adjusts the manufacturing and distribution in real time, and then that allows new products to go from their design to store shelves in as little as 15 days compared to the industry average of 6 months. So that's like a huge win. Okay, so just one last thing which is not on the slide, which is also related to called omni-channel integration. So modern retail data science, they integrate online and offline customer touch points. So the classic example for this is buy online and pick up in store program. I think a lot of retailers do that now, but as an example, Target, one of the pharmacy giant retailers in the US. So they started off this connecting the in-store purchases with online browsing and mobile app usage, and made it a uniform loyalty program data to unify customer profiles. So this helped them increase their digital sales by 141% in the year 2020. So personalizing the customer experience, I'm sure everybody knows that today's customers expect a lot of personalized experience when you're shopping. And then to achieve that, again, an example of Sephora, who is also a big retailer today. So they, according to them, there's 8 core elements that can help them and the brands keep the pace. So what are those 8 key elements? First, manage the data or data management. So make sure you develop a multidimensional view of the customer, basically your customer profile data, quality taking precedence over quantity, having the right data, etc. Then in terms of decisioning, there are a few things that you have to take care of. Customer segmentation and analytics. Basically, you need to be very clear on how you're going to be segmenting your customers, what are the value triggers, and then provide the customer scoring. Create a library of campaigns and content that can be matched with customers. So that's all the marketing campaigns that you can think about. Then a campaigning coordination, basically a decision engine which will create a multi-channel decision engine to prevent conflicting messages and drive maximum value per touch point. From a design perspective, you need to have a cross-functional team, ideally co-located, to manage weekly deployment in a test and learn culture for faster results. So to make these campaigns successful, secure the right capabilities and talent, often by setting the top right. Basically, your leadership should be agreeable to that. And lastly, enabling technology, basically a optimized technology platform. It doesn't have to be you have to build out it from scratch. You can start with your existing technology and then squeeze value from it first. Test and learn. Don't wait for achieving 100% perfection. It's not going to happen. Get started and then improve over time using the analytics and the feedback. So again, just a quick short video, since I don't, can you just confirm if you can hear the audio now?
Yes, sir. It's audible.
Thanks.
Yes, sir, it is audible.
Thank you.
Yes, sir.
We have a lot of retail companies that shape the experience around their product catalog.
Usually the business model didn't really change in the last 30 years. It was still brick and mortar with the catalog, and with the same paradigm just shifted to online.
Any business that's today been able to develop a data-driven business would find themselves perhaps naturally succeeding in being an AI-driven business. You have several layers of competency, which overall will allow the business to move towards more automated decisions, or some happy medium where you have data-driven decisions, which you can then combine with human intelligence.
Technology has to be always abstract. As end users, as customers, for you, it has to be that pure magic, that things just happen exactly when you expect them to happen.
And so if you think of, you think of a lot of our e-commerce businesses today, they use recommendation engines, and they're starting to weave personalization into that e-commerce journey.
The big example is Apple, the whole experience of the product, that it just works, and it works magically. It's almost second-guessing your thoughts.
I think you can move a step beyond that to a scenario such as Netflix or Spotify, where the customer experience, user experience, is centered around using machine learning to understand more about the customer, and based on that understanding, shaping the user journey around them. And so the question would be, where is the Spotify or where is the Netflix of retail? And I think making that jump would be made possible by the use of machine learning and AI. And over the next couple of years, we're going to see several examples of these emerging.
So I think we are just at the beginning of the journey. And this is exactly where I see the majority of retailers actually moving to that space.
Okay, so I think that gave you a good flavor of like the scope of data science. It continues to grow in the retail space. Next, we move on to finance. So finance, typically, like I mentioned, there's a few applications, primarily fraud detection, risk assessment, and other applications. So talking about fraud detection, so a lot of algorithms analyze the bank's transaction data, financial institutions' transaction data, and then they prevent fraudulent activities effectively. MasterCard is a classic example. So they built a decision intelligence platform, which actually evaluates 160 plus variables for each transaction in milliseconds, reducing false positives by 50% and increasing fraud detection by 30%. Now, what do these systems employ or like look at from a data perspective? They look at anomaly detection to identify any unusual transaction patterns. They look at behavioral biometrics, analyzing typing patterns, device handling, etc. They look at network analysis to identify any connected fraudulent accounts, ML models that adopt to evolving fraud techniques. They also look at real-time transaction scoring and rule-based filtering. Another example is PayPal. So PayPal processes over 10 million transactions every day, and they also use a lot of deep learning models to analyze transaction patterns, device information, and also user behavior. And they're able to detect fraudulent activities up to 95% accuracy. And they're able to save almost 145 million US dollars annually. For risk assessment tools, again, financial institutions use a lot of risk analysis to evaluate potential investment and credit risk. Goldman Sachs is a bank. They use natural language processing to analyze the quarterly earning calls, news articles, etc. JP Morgan has a platform called Coin that actually reviews commercial loan agreements in seconds instead of typically if you hire a team of lawyers, they're going to spend thousands of hours to review those agreements. So this platform can do it in seconds. And other applications in finance are typically in the stock market, banking, and fintech sectors rely on the data science technologies for security as well as decision making. Charles Schwab is a financial institution. So they have this intelligent portfolio system that uses algorithms to create personalized investment strategies based on your, as a customer, your risk tolerance, goals, and market conditions. Okay, so again, a quick short video on how fraud detection.
How does data science transform the insurance industry? A question worth pondering upon. Data science, the blend of mathematics, statistics, and computer science, has become an integral part of the insurance industry. It's like the secret sauce that's adding zing to the traditional, often bland insurance operations. It's being used to assess risks more accurately, making sure that insurance policies are priced just right. No more wild guesses or gut feelings. It's all about precise calculations now. It's also making waves in fraud detection, helping insurers spot irregular patterns and suspicious activities. Data science is like the detective of the insurance world, sniffing out anomalies and keeping the industry fair and square. Moreover, it's playing a pivotal role in trend analysis, helping insurers decipher market patterns, customer behaviors, and future risks. It's like having a crystal ball, but one powered by algorithms and big data. Data science hence proved to be a game changer for the insurance industry, paving the way for smart and efficient operations. Now, imagine a real-life scenario where data science plays the detective in an insurance company. Let's delve into a captivating case study that showcases how data science can turn the tables in the insurance sector. We'll look at a large-scale insurance company that was grappling with an influx of fraudulent claims, draining their resources and undermining their trust with genuine clients. The company turned to data science, specifically predictive modeling, anomaly detection, and network analysis, to tackle this issue head-on. The first technique, predictive modeling, was used to forecast potential fraud cases. By examining historical data of fraudulent claims, the model could predict with impressive accuracy which current claims had a high likelihood of being fraudulent. The second technique, anomaly detection, was like a high-tech alarm system. It was designed to flag claims that deviated significantly from the norm. For instance, if a claimant submitted an unusually high number of claims in a short period, the system would raise a red flag. This allowed the company to focus their investigative resources on these potential fraud cases. The third technique, network analysis, was used to unveil hidden patterns and relationships. It helped to unravel complex fraud schemes where multiple entities were involved. By analyzing connections between claimants, providers, and claims, the system could identify suspicious networks that might be collaborating to commit fraud. The impact of these techniques was transformative. The company was able to save millions of dollars by preventing fraudulent payouts. But the benefits weren't just financial. The company also saw a surge in client trust. With the assurance that their premiums weren't being wasted on fraudulent claims, clients felt more confident in their relationship with the company. Moreover, the company's success in combating fraud sent a strong message to potential fraudsters, deterring them from targeting the company in the future. This further reinforced the company's reputation and credibility in the market. This case study clearly illustrates the power of data science in detecting fraud, safeguarding the interests of both insurance companies and their clients. So, what does this all mean for the insurance industry? Well, let's take a moment to recap what we've covered. Data science, with its analytical prowess, has become an indispensable asset for insurance firms. It's the secret weapon that enables companies to sift through vast amounts of data, uncovering patterns and insights that can transform their operations. From detecting fraudulent claims, an issue that has plagued the industry for decades, to evaluating risks more accurately, data science is revolutionizing insurance. Remember the case study we discussed? It perfectly illustrates how data science can help a company save millions by identifying fraudulent activities swiftly and accurately. The impact is substantial. Insurance companies are now able to operate more efficiently, make more informed decisions, and provide better services to their customers. In a nutshell, data science is not.
So I think that gives you a pretty flavor in the financial world. Again, it's making data science is making strides. There's like a lot more things happening every day, new things coming up. Moving on to the next industry sector, we're talking about manufacturing here. So in manufacturing side, we have a predictive maintenance, quality control automation, and also digital twin technology. So talking about predictive maintenance, we have a lot of ML models that actually analyze sensor data, and they're able to predict the equipment failures even before they occur. So that reduces a lot of machine downtime and production downtime. Siemens, as you know, the Siemens is a famous company. They implemented predictive maintenance systems across their gas turbine fleet, and they were able to reduce unplanned downtime by almost 30% and also reduce maintenance costs by 20%. Now, again, to what these systems typically look at or integrate, they take data from real-time sensor data from the different equipment like vibration, temperature, pressure. They also look at historical maintenance records, failure patterns. They look at the operating condition data, like what is the load of the machine on the machine versus speed, environmental factors, etc. Manufacturing specifications, or if there's any tolerance parameters for each of those machines, that's also taken into account. One other example is one of the semiconductor manufacturer. What they did is they deployed an IoT sensor network and also combined with a machine learning system. And they were able to detect subtle anomalies in equipment performance 72 hours before the failure would occur. So this actually helped them increase their production yield by almost 4.5% and saving them 20 million annually. Next, talking about quality control automation. So we have computer vision and deep learning systems that inspect products at scale. They identify defects with great accuracy and then manual inspection, manual quality checks. BMW is a classic example. So they implemented a computer vision quality control system that analyzes 100% of their car body welds, and they're able to detect microscopic defects with almost close to 100% accuracy. And that actually exceeds the human accuracy of 92%. Another implementation example was a pharmaceutical manufacturer. So they used a multi-layer neural network, which was able to analyze spectroscopic data during production. And thus that ensured that the chemical composition consistency and batch failures were reduced by almost 74%. Lastly, in the manufacturing sector, digital twin technology. So basically that it means that virtual replicas of the actual physical assets can be produced easily. And based on that, the organizations are able to simulate, optimize, and do real-time monitoring of manufacturing processes. Great Electric GE's digital twin technology for jet engines. Those engines actually combine physics-based models with machine learning to simulate performance under various conditions. And that actually has helped them optimize maintenance schedules and extending component life by 25%. Quick short video again talking about the manufacturing industry.
The cost of downtime in manufacturing environments can be significant. Effective predictive maintenance helps avoid machine failures and unplanned downtime, increases productivity, reduces operational costs, and improves output quality. Predictive maintenance systems use machine learning algorithms to process real-time sensor data on temperature, pressure, torque, vibration, and other key parameters to determine when failures are likely to occur. Accurate historical data is essential for training predictive models about precursors to failure states. In this example, we will train our model with the time series data provided by NASA about how ball bearings behave under various failure conditions. This dashboard displays the NASA sensor data and helps the data science team identify outliers, clusters, trends, and anomalies. This next dashboard displays the real-time output of our predictive model. It shows how our machine learning algorithm is assessing the health of each bearing. Altair software stores the historical training data in a specialized high-performance database. Altair software makes it easy to import, cleanse, and prepare the training data to help ensure that our model will be as accurate as possible. Next, we use the software's visual workflow tools to construct our predictive model and train it with the NASA data. Our model will make its predictions based on the 10 parameters we found in the historical data set with the most predictive power. Altair makes deploying the model easy as well. Once we've deployed our model, we can set up real-time triggers to notify us automatically when the model predicts an imminent failure. Our workflow includes feedback loops that continuously monitor how well our predictive model is performing and continuously improve its accuracy by updating its training with new data. Altair offers a comprehensive set of data preparation, machine learning, and data visualization tools that enable you to build out, deploy, and manage highly precise predictive maintenance systems. Contact us today to learn how Altair.
So Altair is actually an example of typically when we talk about building machine learning models, we talk about R, Python, and etc. Altair is one of those off-the-shelf tools that's already available. It's very easy to use. It's not really doesn't really require you to do a lot of coding. So you can just upload the required data and select some predefined models. Configure some setups, and then you will be you can actually start to generate actual machine learning prediction models. So that was a use case in the manufacturing industry where Altair is used. Next, we move on to. In the interest of time, I am going to skip this. So we move on to the next one. So the next sector is transportation. So typically for transportation, we have machine learning algorithms that analyze traffic patterns, weather conditions, and historical data to determine the optimal delivery routes that, let's say, for example, a logistics company has to use for their deliveries. So UPS is a very famous delivery company based in the US. So they have this on-road integrated optimization and navigation system that can optimize delivery routes for 55,000 drivers every day. And that actually helps them save almost 100 million miles annually and also reduce fuel consumption by 10 million gallons. Now, these systems, they consider real-time traffic conditions, construction updates, package delivery, time windows, priority levels, vehicle capacity, driver constraints. They also look at weather forecasts, seasonal traffic variations, fuel efficiency optimization, etc. So as an example, one of a mid-sized logistics company, they actually implemented machine learning-based route optimization, and they were able to reduce delivery times by almost 17% and fuel cost by 22%, and also they were able to improve on-time delivery rates by from 89 to 96%. The other use case for transportation industry is demand forecasting. So similarly, machine learning models, they use historical ride patterns by different parameters, like you can see by location, by time, day of the week, or they will even look at special event schedules, like if there's a sports event occurring or concerts, etc., weather conditions, public transit disruptions, etc. So one classical example is the New York City MTA, basically their metro transport system. They use predictive analytics to forecast the train ridership, optimize train scheduling, and also staff deployment. And this has helped them with the 15% reduction in wait times during peak periods, and also 9% improvement in on-time performance. And lastly, autonomous vehicle development. So again, we are familiar with the autonomous vehicles like Tesla. So deep learning models process sensor data in real time to make the autonomous vehicles work. Quick case study from a logistics network perspective.
Logistics companies often have really big networks, which are complex to analyze for efficiency and capacity utilizations. In the very competitive logistics industry, it is crucial to have an organized network and not leave money on the road. Network evaluation is quite complex as there are many constraints to consider: date restrictions, vehicle capacities, driver schedules, number and duration of stops, laws of the countries, etc. In this case study, we're going to explain which solution HAMS can offer to bring your logistics setup to the next level. Let's jump into a use case. Let's look at a logistics company with routes all throughout Europe and with several hubs. One common issue is that some routes and vehicles in the network are less efficiently used than others. An example: here we have the same route where two trucks are driving 2 days apart. Taking a look at the trucks, we see that one is using only 40% of its full capacity, the second one 50%. We can help you find suboptimal truck shipments and compute smarter ways of fulfilling the order, for instance by combining shipments from 2 trucks into one. Another usual problem is the complexity of the logistics network and finding the optimal route and hubs to optimize the overall network setup. One example would be trucks doing multiple stops on their trips because they carry goods for several different destinations. It's hard to evaluate whether the setup of routes and hubs is optimal. For this specific case, is this the most optimal setup of routes and hubs? We can evaluate your network, highlight bottlenecks and inefficiencies in tool setups, routes and hubs, and propose a better setup. Meaning less kilometers, higher capacity utilizations, less time spent on the road, less CO2 emissions, and more revenue. As a conclusion, there's likely a lot of potential to improve your logistics network. Considering the specific constraint factors through domain knowledge combined with expertise in machine learning and data science, we help you to evaluate the performances and utilizations and further suggest improvements to increase your revenue. If you want to take your logistics network to the next level.
Okay, so the next sector we're looking at is energy sector. So within energy sector, we have consumption forecasting, basically energy companies trying to predict what will be the energy consumption, how much they have to produce, and then how can they optimize their energy grids and also any preventive maintenance. So the machine learning models in the, for example, the UK national grid, which is the electricity grid there. So they use historical consumption patterns by region and time. They use weather forecasts like temperature, humidity, wind, calendar effects, holidays, weekends. When typically the usage can go high. Electricity usage at homes can go high on holidays, weekends. Economic indicators and industrial activity levels, and also population density and growth patterns. Then we have smart grid optimization. So here again, AI algorithms can actually balance the electricity load distribution. So they can integrate renewable sources of energy like the solar energy and others. And these can actually prevent any outage or create backups for if there's any outage in the power grids. As an example, Google DeepMind, they partnered with the UK National Grid. They managed to develop a reinforcement learning system that helped them predict renewable energy output 36 hours in advance. Again, they were able to achieve 90% accuracy, and it helped reduce the need for fossil fuel reserves by almost 20%. Another example of implementation was California, a utility company. So they use machine learning to optimize battery storage, charging or discharging cycles, again, based on predicted solar generation, grid demand, electricity prices, increasing renewable integration. And at the same time, they were able to reduce peak demand charges for customers. And lastly, preventive maintenance, something similar to the manufacturing sector. So basically, predictive analytics help them identify any potential failures in the infrastructure before they actually happen. So, for example, Duke Energy is a company in Europe. So they implemented sensors, machine learning systems across their energy transmission network. So they were able to reduce their transformer failures by 35% through early detection. So this system basically it looks at the oil composition in terms of fossil fuels, temperature patterns, and also the electrical load data, and they're able to identify any components that are getting deteriorated before any big failure happens. So a quick example of the energy sector.
Power generation and demand forecasting AI. Operation of renewable energy systems. Toshiba's technology. Aiming at a carbon-free society, the introduction of renewable energy, including photovoltaic or PV power generation, has been expanding. However, in the case of renewable energy, for instance PV generation or a wind turbine, the power generated can be drastically affected at any moment by fluctuations in sunshine or wind due to the season and the weather. Precise forecasts of changes in ever-changing demand and the amount of power generated will enable a well-balanced and efficient supply of power. Efficient operation of renewable energy can greatly contribute to the realization of a carbon-free society. Photovoltaic power generation forecasting technology can make this possible. This technology combines Toshiba's weather forecasting system and AI. Our weather forecasting system generates data such as insolation intensity, reflectance of sunlight, temperature, and wind speed to estimate the amount of power generated. In addition, AI estimates the installation status of photovoltaic power generation facilities. It offers excellent explainability for forecasts and highly precise results. It won the PV in Hokkaido Photovoltaic Power Generation Prediction Technology Contest Grand Prix. It is achieving an excellent reputation. Changes in power demand influenced by the weather are forecasted very precisely by AI. By combining that with power generation forecasting, stable operation of a power system and a network using renewable energy can be realized. Forecasting the amount of power generated and demand for efficient operation of renewable energy systems. Toshiba's technology. Imagine the future. Create the future.
Okay, so we move on to the last energy industry sector, that will be agriculture. So in agriculture, data-driven farming or precision farming, we use sensors, drones, and also satellite imagery to optimize crop management at the individual farm level. As an example, John Deere's See and Spray technology uses computer vision to identify weeds among crops. So basically, they're able to use satellite imagery to identify if crops have weeds, and they apply herbicides only when needed. Thereby, they're able to reduce the chemical usage, which is also a big environmental concern today. And they're able to reduce it by almost 77%. So modern precision agriculture systems, they typically, what kind of data they look at? They look at multispectral imagery revealing how the plant's health is. They look at soil moisture, soil's nutrient levels, pH levels by location. They look at the microclimatic condition across the different fields. They also look at pest and disease identification through computer vision, historical yield at subfield resolution. One of the case studies that was done is a 5,000-acre farm in Iowa, again in the US. So they implemented a variable rate technology guided by soil sampling and satellite imagery, and they were able to reduce fertilizer use by 30%, and they were also able to increase their corn yield by 12%. So basically through applying targeted application based on the specific field conditions. Next in agriculture, crop yield prediction. So this is again forecasting, okay, what would be the yield of my crops this year based on the different conditions. So again, we have a lot of machine learning models that can actually forecast harvest quantities months in advance. So that in turn also helps farmers plan their supply chain planning and also plan their finances. As an example, the Climate Corporation, which was recently acquired by the Bayer company. So they use deep learning to predict corn and soybean yields with up to 80% accuracy 3 months before the harvest. So the models they use, they integrate historical yield data, crop variety information, weather data, seasonal forecasts, again, satellite and drone imagery showing how the crops are growing, soil conditions and management practices, and lastly, regional pest and disease prevalence. Another example of implementation is a major food processing company. So they use predictive analysis to forecast tomato yields within 5% accuracy 8 weeks before harvest. There again, the benefits there are they're able to optimize their processing capacity. They can schedule their labor supply accordingly, and also the supply chain logistics, and ultimately reducing food waste. The last use case from an agriculture sector perspective is livestock monitoring. So a lot of IoT sensors and computer vision, they can actually track animal health and behavior. So it helps the livestock farmers to intervene early and manage the health of the animals earlier. Connectera is a specialist organization in this sector. So they have this IDA system. So they use neck mount. So basically sensors that are tied to the neck of the animal. And these sensors are able to, together with AI, they're able to monitor for example, the dairy cow's behavior. And they're able to detect health issues 24 to 48 hours before any symptoms even appear. Increase the milk production by 15%. Okay, so again, a last video on the agriculture segment.
Farming is complicated business with considerations like soil and crop types, topography, climate, and how to minimize inputs while maximizing yields. Yet a one-size-fits-all approach is still frequently used. Planting, watching the weather, applying uniform amounts of water, nutrients, and pesticides, manually inspecting fields for signs of stress or pest infestation. Sometimes all of the variables align. Sometimes they don't. Crop yields fluctuate. So do margins. These conventional methods not only have the potential to waste time and resources, they can negatively affect soil and water quality too. Rarely do they significantly boost crop productivity. Satellite and UAV imagery offers an effective way to survey small to large-scale operations and assess crop health. NV analytics can then be used to pinpoint areas of crop stress to determine when, where, and how much water, fertilizer, and pesticide is needed to produce a healthy crop. Our data and analytical solutions bring science to the field. They are designed for growers with little to no experience with remote sensing techniques to enable them to make better soil, water, and crop management decisions. So take the guesswork out of agriculture. Contact us today and learn how to minimize losses, maximize yields, and boost profits.
Okay, so I think we have seen the different industries and various use cases, some of the case study examples. I'm sure that should have given you a lot of insights. And I think the last topic I had was just to quickly wrap up in terms of launching data science projects in your industry or in any industry, right? So some of the basics and overview of what we need to look at. In the interest of time, I probably am going to skip this. We're just going to the content. So the best project practices typically for a data science project is the initiation level and engagement level. So we have to be very clear with the project goals in terms of the measurable outcomes for the success. So they are going to be guiding our planning and execution. Stakeholder communication becomes very critical as well, because that's where you need to build the trust and ensure the stakeholders' needs address. It's not just picking up any project and doing it, but making sure that it actually adds value to the stakeholders for whom you're building your data science project. And at the same time, aligning all the expectations with the objectives, or getting all the stakeholders to align with the uniform objective. Because if you have different expectations from different stakeholders, then you're going to go, your project is going into a big catastrophe. Quickly on the data science life cycle. So there are, at the high level, again, there are 5 major stages in the data science life cycle. So starting off with defining and understanding the problem. So a problem cannot be solved if you don't know what the problem is, right? So a lot of those industry executives, they usually go to their data science team, and then they'll claim there's a problem, and then the data science needs to solve it. However, most of the cases, you'll be surprised that they will have no idea how to actually state or articulate the problem, or why it needs to be solved, what is even the connection between the business case and the technical is. So the very first step, which is critical, is to produce a very clear definition and understanding of the problem or the business case. Then translate that into a data science problem with actionable steps and goals. So we need very clear, concise communications with the business executives who's asking for the solution. Ask all the questions so that we don't produce any contradictory results. Solving a problem with the data takes a lot of work, as you've been, I'm sure, with all the sessions that you've been through. So might as well do the first step in the right with the right amount of time. So one of the key questions that you should be asking somebody who's asking you for a project is, how is the problem, or what is the benefit that the company or organization is going to get by solving this problem, and how it fits into other processes of the company. Second step is data collection. Again, a very huge exercise in itself. So if you have asked the right questions, you now have a clear idea of what problem you're trying to solve, then you should be well prepared to collect the right data required for the job. So I say that you should be well prepared, but data collection actually can turn up all sorts of problems. So not all companies maintain very good data sets, excellent data. Again, not all companies necessarily have the right data for the job. So more time should be spent on this step to ensure that you have the right data from the beginning. Again, these projects take a lot of time and effort, so might as well do it right at the first instance. In addition, it's always a good idea to collect more data that you think you'll need, because data sets that may be incomplete or erroneous for other reasons, it's always a good idea to have extra data just in case. So this way, your entire project can still be completed regardless of the quality of data. Third step, data cleaning and preparation. Again, I think you as part of this you had a session entirely on data cleaning and preparation as well. As I described in the previous step, collecting more data than you think you will need is always valuable, because once you start combing through the raw data with a fine-toothed comb, you will see a lot of incomplete or erroneous data. So the reoccurring theme of this process is that you must do each step right the first time to reduce the potential of having to do all over again. So data science is all about working smart and not hard. This means, again, in order to produce the right models in the step 5 of the process, you need to properly clean and prepare the data you're using. You have to remember that your models will potentially change the way your company does business, which means, again, you have to be right for the first time when you're developing your models. Some of the key types of erroneous data you need to be aware, like incorrectly formatted data, corrupt data, duplicate, null values, etc. And this step in the data science lifecycle is typically seen as the longest step. And typically, data scientists also argue that this is like 80% of your work of your entire project. And then step number 4 is your exploratory data analysis, and that's the topic I covered on day 2. So this is again the step where you actually typically where you write some code and start looking at the data characteristics, and then complete by developing some data visualization. So you'll be able to see patterns, you'll be able to spot anomalies, you should be able to do some kind of hypothesis testing, check assumptions, etc. So there are a lot of tools available to do this. For Altair was an example which I was showing in one of the video earlier. So a lot of ready-made tools are available. But if you're coding savvy, then of course you can go to R, Python, and Matplotlib, etc. Lastly, model building and development. So this is the kind of second and final fun step of the data science project lifecycle. So this is where you split your data into training and test sets, and then you start to build your machine learning models. Then you'll determine whether you need to create a supervised or unsupervised machine learning model. Then, so based on the use case, based on the client segments, but based on the requirements, you make those decisions. Again, your models may need a few tweaks here and there, but again, if you have done all your previous steps correctly, there shouldn't be any major changes required. Finally, while the data science project's lifecycle may seem very obvious, is not really taught in all your online certificates or courses. So there's actually a huge disconnect between the technical skills that you learn, like learn your R, Python, etc. But then you don't know how exactly to implement the project. That becomes a complex learning process. However, by learning this basic structure, you'll become a more well-rounded data scientist, and you'll be able to answer any kind of life cycle questions that may be thrown at you. Okay, so it's always better to position yourself in the team and deliver a good data science project. With data science projects, some of the issues, I think, self-explanatory data quality issues, model accuracy challenges, and aligning the end outcomes with your stakeholders is always a big challenge. I've included a lot of available resources in line. I think the organizers will be sharing the deck across to the participants, so I won't go through in detail, but this is again self-learning material that you can actually use, refer, or even use data sets to do your own practice, build your own projects. To conclude, opportunities are abundant across industries for data science. Data science has created vast amount of opportunities, as you can see, as you saw from some of the case studies earlier, and it is not stopping anytime soon. It's just continuing to grow. Learning from examples, real-world examples, actually give you more insights rather than just sticking to learning the technical skills. So I think I would always recommend that in addition to picking up your technical skills, look at more real-time examples to broaden your horizon, engage interactively to enhance your skills, and also understand data science concepts. And lastly, apply the best practices for successful data science project delivery. So with that, I come to the end of my presentation. I will hand it back to the organizers.
Yes, sir. Yeah. Good evening, everyone. On behalf of the organizing team, I would like to sincerely thank Mr. Mohammad Riaz for giving us such an informative session on case studies and industry use cases of data science. You've actually explained and made us very clear about how data science is being used in different industries like the retail, finance, fraud detection, and so on. The examples that you have given has really made us understand how the data science makes the business easier and how it improves the profit and gives a big impact in the industry. So we would really appreciate the way in which you have carried the session, and we would like to really thank you for having spent the time and having given us such a good session, sir. Thank you, sir. Thank you. Thank you for coming and giving us such a good session. Thank you.
Yeah. Thank you, and thank you for the opportunity.
Thank you. Dear participants, we have now come to the end of the FDP and the end of the 13 session number 13. Followed by, you will be shared with a feedback link for this particular session, that is the session 13. So you can send the feedback, and at about 6:45, the link will be shared for you to take up the assessment exam. Okay. Now, I would like to propose the vote of thanks on behalf of the organizing team. So, good evening, dear participants. It is my honor and privilege to deliver the vote of thanks on behalf of the organizing committee for this faculty development program. First and foremost, I would like to express our gratitude, sincere gratitude and heartfelt thanks to our resource people, Dr. Brito, Mr. Mohammad Riaz, Dr. J. Priyadarshini, Professor Venkateshwar Rao, Professor Rubel Mario, Dr. Syed Ibrahim, and Professor U.S.N. Raju, and P.S. Rajan, and Srinivasa Raghavan. So these were the resource people who had given us such wonderful sessions and insight on the topic of the FDP. So I would I would like to express my sincere gratitude and heartfelt thanks to these resource people who have shared their time, knowledge, and expertise, and who have traveled with us throughout this session. So their thought-provoking presentations and interactive engagements has inspired all of us to explore deeper into the topics that were handled by them. And now I would like to extend my sincere thanks to our management and our principal, Dr. Purnachandra, for their constant support and encouragement, without which this program wouldn't have been possible. I'd also like to give a special mention to the organizing team, the coordinators, the teaching staff, technical staffs, and the teaching faculty members who have worked tirelessly behind the scenes to ensure that everything is running smoothly from behind. Now, to all the participants, I would like to thank you all for your enthusiastic involvement and your active participation. Your engagement has really made this program a true success. And finally, I would like to thank the supporting institutions and the organizations who have given the approval for the faculty members to participate in the FDP. So I would like to once again thank each and every one of you for making this FDP a memorable and a meaningful experience. Thank you, and wishing you all a successful journey in your successful academic journey. Thank you. Dear participants, I would like to hear a few words of feedback from some of you who can turn on the audio and give me the feedback.
Madam, myself R. Mahesh Kumar.
Yes, sir.
Working as assistant professor in Annamachara University, Rajampet, madam.
Okay, sir.
I'm belonging to ECE branch now. I'm working as assistant professor. but I completed recently data science domain in NPTEL courses. So we want to develop in computer science domain also in multivariate domains. So for that, it is also helping a lot. It will also help a lot this workshop, this FDP.
Okay.
And not suggestion, you will do it, but telling within 2 to 3 days after completion of this, that links with the prior permission from that researcher, that is research persons, will you provide in the group, not group, in the link itself, their email addresses, madam, that professors,
Yes, sure.
with their permission. It will be good. It will be continuous learning, na?
Okay, sir. Yeah, we'll do it, sir. I think the drive link is shared to you. The session videos
Yes.
has
Up to
been
8,
shared.
it is downloaded, madam. Up to 8, you have shared. 9, 10, I think
Yes,
it
sir.
is not.
Yeah. 9, 10, 11, 12, 13 is pending. We will do it today, sir.
Along with PPTs, madam.
Yes, sir. We'll do it, sir. Yes. Sir.
Without that, madam, I can say 5-star rating like this, not like that, but effective teaching, madam. All the resource persons effectively taught with real day, the daily life examples, real life examples. That too, today a professor is in US and Raju sir. Make use of that, like our students, to the students, he will explaining in a PPT with marker in a classroom. So like he clearly explained image processing, everything. Madam. That's it, madam, from my side.
Okay, sir. Thank you. Thanks for having given us such a positive note, sir. Thank you, sir. Thank you.
Welcome, madam.
Yeah, sir. Thank you. Anyone else? Can I expect some feedbacks from any other participants? Okay, now I would like to request all the participants to, yes, sir.
Ma'am, the session was very useful, ma'am. In the way that implementation of deep learning algorithm, I have completed my PhD in video image processing. But deep learning is a little bit hardcore concept to understand. So that FTP and gathering of this many resource person is not that easy. Thank you so much for that.
Yes,
really
sir, we
appreciate
understand.
your management and faculties for their support to enhance the knowledge. Thank you so much.
Thank you, sir. Thank you for the feedback, sir. Thank you. Thank you.
Madam, let
Yes,
me one. I have turned on camera like this here.
Okay.
Where to fix? Am I visible now, madam?
No, sir, not visible, sir. One second, I'll give an instruction to everyone, sir. I would like
How
all the
to-
participants to just turn on the video or the camera for just 1 minute so that we can have a group photo, which is also a mandatory procedure for us, for the
I know, madam,
organizers to submit. Yeah.
but it is not showing that. Even though I
Sir,
am
on
turning
top
on.
you can see camera. You just turn on that,
Yes.
sir.
I'm clicking on that, madam. But in clicking integrated camera, you are all visible, madam.
Yes,
From
sir.
my
Not.
side. Where
my camera click on video symbol.
ఎక్కడ
On top you can see right top.
చెప్పినా ఆన్ చేసినాను వీడియో సిమ్ లో.
Have you taken the
cross mark gone
screenshots?
away, sir? Has that cross mark gone away?
No,
Just
it's
check
going
whether
on.
still
It is
the
not
cross mark
going.
is there.
Yes.
Okay.
What is
I really don't understand, sir. If you, we can wait for a few minutes. If you want, you can go out and come. You can log out and come otherwise.
Oh, log out 1 minute.
Yeah. Just give a trial, sir. I would request more participants to come online. Come online. Please turn on your cameras. I need a pic with the full photos on the screen. I could see only 3 or 4 of them.
Yes, still turn camera on. Control Shift 1 minute. Control Shift O.
Other participants, please come on video. Yeah, turn on the.
Hernad Reddy sir. Hernad Reddy sir.
సార్ చెప్పండి.
కంట్రోల్ షిఫ్ట్ అని కొట్టినా ఏం రాలేదు సార్. మళ్ళీ రీజాయిన్ అయినాను.
సిస్టమ్ లోనా?
ల్యాప్టాప్ లో వెబ్ కెమెరా ఆన్ లో ఉంది. ఆల్రెడీ లైట్ వెలుగుతుంది నా వెబ్ కెమెరా.
సెల్లో జాయిన్ అవ్వ లేకపోతే సెల్ మొబైల్
ఒక నిమిషం ఉండు.
మొబైల్ లో జాయిన్.
ఇన్ని రోజులు ఉండి లాస్ట్ కు వన్ మినిట్. దేవుడా.
Baisley?
Yes, ma'am.
Yeah, I think you're capturing.
Yes, ma'am. Yes, ma'am. It's done.
It's done. Okay.
One minute, madam.
Yeah.
Yes, sir.
Yes, sir. We are waiting.
We are waiting.
I am trying to log in mobile phone, madam.
With your mobile, yes, sir. Take your time. We'll wait.
Ma'am, good evening, ma'am. This is Dinesh from Mission Engineering College, Coimbatore, ma'am.
Yes, sir. Good evening, sir.
Ma'am, did you remember me? I'm your pastor students before 12 years in St. Peter's University. 13 batch of MTech at St. Peter's University, ma'am.
Yes. I remember. 2013 batch. Can you name your batchmate?
Ma'am, batchmate Manjari and Pavitra at university, ma'am. 11 to 13 batch.
Okay. Maybe I slightly remember, but not a clear.
Ma'am, Vaishali ma'am also very familiar to us, ma'am.
Yeah, she was with us. We were all together.
Yeah, ma'am. Actually, ma'am.
Yes,
Actually,
sir,
at that time only was completed your doctorate, ma'am. Is my correct?
Yes, sir. Yes, in 2000.
Ma'am, after completed my PG, I went to Coimbatore. Right now, I have completed my doctorate in Anna University. I am also working as HOD in IDS department, ma'am.
Very good, sir. Congratulations. Fine. Good. Very good.
Ma'am.
Stay in touch,
It's a
sir.
nice FDP, ma'am. Nice
Keep in
FDP,
touch.
ma'am.
Numbers are there in the
Yes, ma'am.
brochure. Yeah.
Yes,
Keep
ma'am.
in touch.
Yeah, ma'am. Thank you, ma'am. Thank you, ma'am.
Yes, sir. Happy. Your friend has got connected, sir. We are waiting for him. I think he's not online. He's not found online.
Madam, I am R. Mahesh Kumar, madam.
You come, sir. No, your video is not on, sir. No, your video is not on, sir.
Phone lo kuda on chesnanu.
In phone also,
I am able to see.
Can you check out what is the problem?
Yes.
I think
Yes.
He's on. He's there.
Yes.
Okay.
Yes, sir. But it is moving. The picture is moving. He's moving.
So hold your mobile.
Yeah. Yes, sir. I've taken the screenshot. Thank you.
Okay, then. Yeah, I think you can turn off. And now I think I'll like to highlight in the list of procedures.
My photo came, madam. Is my photo came, madam?
Yes, sir. You are visible. You are visible.
Yes, sir. Okay, then.
Okay,
yeah.
madam.
Okay, sir. Thank you. Thank you, all of you. Thank you, all participants. Thank you. So now I'd like to highlight in the list of procedures, which is very minimal requirements, I would say, to take away your certificates. All of you will need 80% of attendance, and all of you will need a minimum score of 70% in the assessment exam, and you should have filled up all the feedback forms. So these are all the mandatory procedures, and you should have also registered in the Atal portal for this participation. So these are the 3 mandatory conditions which you have to fulfill to take your certificates. So now shortly in another 5 to 10 minutes, the assessment link will be posted. So you can all complete the assessment and submit them. We will receive them, and based on your score, you will receive the certificates. You will receive the certificates from Atal directly. So hope everything is clear with you. If there's any doubt, ask me. Yes, madam.
Ma'am, I am Soumya. Actually, Wednesday while attending the class, there was a power cut in my area.
Okay.
I attended the class up to 8:15 or 8:20. After that, only power cut happened. I'm not able to receive that feedback immediately.
Okay, ma'am. No, don't worry, ma'am. If you have 80